Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have this function, and it's a function of three variables, x, y, and z, and we have to find 9 second partial derivatives to this function. Now, since we have to compute second partial derivative, we have to first compute the first partial derivatives and then take the derivative of that one. So, to start, let's call this function f. So, this is f of x, y, z, okay. And we are going to use the notation fx to represent partial derivative with respect to x, then fy and fz. Okay, so let's start with the first partial derivative of the function with respect to x. Remember, if we are taking the derivative with respect to x, y and z, they are both constants. All right. So let's look at each term and take the derivative separately. So first term is x square. There is no y or z. So its derivative is 2x. For the second term, we have a 3y, and that's a constant because this is with respect to x, and the derivative of x is 1. Third term, there is no x, just y and z, and 4 is obviously a constant. So the whole thing is a constant. So this derivative is 0. And last term also doesn't have any x, so the derivative is 0. So fx is 2x minus 3y. All right, move on to fy. So partial derivative with respect to y. Remember, x and z will be constant now. So first term has just x square, no y, therefore derivative is 0 since it's a constant. Second term, 3x, both constant, pull it out, take the derivative of y, that is just 1. Third term, 4 and z, they are constant. So you write down 4z, take the derivative of y, which is 1. And last term doesn't have any y, just z cube, and this entire thing is constant, so the derivative is 0. So simplify and you get negative 3x plus 4z for f of y, fy. Okay. Lastly, we have to figure out the first partial derivative with respect to z, so fz. Now x and y, they are both constant. Okay, so the first term has no z, so this entire thing is a constant, so derivative is 0. Second term is 3xy, again no z, so everything is constant and derivative is 0. Third term has a z, so 4y, they are constant, so write it down as it is, 4y, take the derivative of z, that is 1. Finally, the last term is z cube, so the derivative of z cube with respect to z is 3z square. And so when you simplify this, you get 4y plus 3z square. Okay, so we have the three first partial derivatives. Now we have to compute the second partial derivative. So each of this expression, you have to take the derivative with respect to x, y, and z. So once again, take this expression fx and compute its derivative with respect to x, y, and z. Okay, so let's start with this function here. So the first one we'll compute is fxx. That means is the partial with respect to x of fx of 2x minus 3y. Okay, so let's think about it. This is with respect to x. So the derivative of 2x is 2. And derivative of 3y, y is constant, right? Because it's with respect to x. So this derivative is 0. So this is 2 minus 0. So this derivative is just 2. Okay. Now let's compute f(x,y), which is the partial with respect to y of 2x minus 3y. Okay. So now with respect to y, so x is constant, so the first term, the derivative is 0. Second term, it has a y, so the derivative is just the negative 3. So this value is negative 3. Finally, for this particular expression, we have to take the derivative with respect to z as well. So that one is f(x,z), and that is partial with respect to z of 2x minus 3y. Okay. Notice that 2x, this term doesn't have a z, so derivative is 0. 3y also doesn't have a z, derivative is 0 because the derivative is with respect to z, and this expression doesn't have any z. So the entire thing is constant. So this derivative is 0. Okay, so we got the first 3 second partial derivative for fx. Okay, moving on. Now let's consider fy. So now we take this expression and take its derivative with respect to x, y, and z. So the first one is fyx, which is partial with respect to x of negative 3x plus 4z. All right. Now be very careful, this is with respect to x, so y and z, they are constant. So the first term is negative 3x, so derivative is negative 3. Second term has z, 4z, so this is a constant, so derivative will be 0. So this is equal to negative 3. Okay. Next we will compute the derivative of fy with respect to y, so fyy. So that is the partial with respect to y of this expression, negative 3x plus 4z. Okay. Now, with respect to y, we're taking the derivative. And look at this entire expression. There is no y. One of them is negative 3x, one of them is 4z. So you have a 0 plus 0 because derivative of constant is 0. So the answer is 0. Okay, last one. In this row, you have to take the derivative of fy with respect to z. So fyz. Okay, so with respect to z of negative 3x plus 4z. Okay. Now, x is a constant because this is derivative with respect to z. So the first term derivative is 0. Second term is 4z, so the derivative is plus 4. So this answer is 4. Okay, so we're left with fz, and we have to do the same thing again. Take the derivative of this expression with respect to x, y, and z. Okay, so the first one is fzx, which is partial with respect to x of the expression 4y plus 3z square. All right. Again, with respect to x, so 4y is a constant, derivative is 0. Okay. Now, with respect to x, 3z square, constant, derivative is 0. So this value is 0. All right, moving on. fzy now. So you have to take the partial with respect to y of 4y plus 3z square. Okay. Since this is partial with respect to y, first term is 4y, derivative is 4. Second term is 3z square, entire thing is a constant, so the derivative is 0. So this derivative is 4. And finally, we compute fzz, which is partial with respect to z of 4y plus 3z square. Okay. Notice that the first term has no z, entire thing is a constant, derivative is 0. Second term, we have 3 and derivative of z square is 2z. So this derivative is 6z. And so we have all 9 second partial derivatives for this function. Thank you.